Application Attacks Part 1. Today we're going to begin with Application Attacks Defined, and then we're going to conclude by talking about some common application attacks. There's a fair amount of information to go over, so let's go ahead and dive into this session. We're going to begin with a definition of application attacks. Due to improvements in modern network security methods, hackers may not be able to easily exploit network resources or devices. As these security improvements have developed, in many cases, the attackers have shifted their focus to application attacks. The hacker will focus on exploiting weaknesses in the software and operating systems that people use every day. In many cases, the security used to protect software from exploitation is not as robust as the security that is used to protect networks. A poorly developed application can often give the hacker administrative control of a system if the exploit is executed properly. And that briefly defines an application attack. Let's move on to the discussion about common application attacks. First up is the cross-site scripting attack, or the XSS attack. The attacker inserts script code into a form on a web page that then gets submitted to the server. You would think that that would be an attack against the server, but it's not. The server then submits the script code to another client system, which then executes the script. It's the client system that receives the script back from the server that is the victim. Cross-site scripting is often used to attack the database servers that are used to support web pages. Then there is the SQL injection attack. SQL is the common language used to manipulate databases. Most businesses and web applications use SQL to retrieve data from databases. To perform the attack, the hacker inserts SQL commands into the application, usually from an input field, knowing that the application will pass the command to the database application. The injected SQL commands will then modify the database, as in inserting a new username and password for the hacker to use in further exploitation. With a buffer overflow attack, the hacker sends more information to the application than the application's memory buffer can handle, therefore overflowing the buffer. The additional information will often be placed in memory outside of the controls that are included with the buffer. If the hacker can get the right information stored outside of the buffer, he or she can execute code with administrative privilege, and that spells trouble. An integer overflow attack is similar to a buffer overflow attack, but involves exploiting the mathematical functions of an application. When a mathematical function returns an integer, that's a number, larger than the memory space that has been allocated to receive it, applications often respond in unexpected ways. And guess what? This represents a security issue. The directory traversal command injection attack is a popular attack against web servers in which the hacker attempts to traverse the web server's directories to the point where he or she can execute commands on the underlying operating system. The attacker manipulates URL requests in order to move through the directories and get to a command prompt on the underlying OS. Once there, they have control. The LDAP injection attack uses the same principle as the SQL injection attack, but exploits LDAP calls instead of SQL commands. Then there is the XML injection attack, which uses the exact same principles as the SQL injection attack and the LDAP injection attack, but it exploits extensible markup language to modify the targeted application. One of the largest threats that network security personnel face is the unknown vulnerability. It's hard to defend against what you don't know. Network and systems administrators expend a fair amount of effort protecting the assets under their control. They can do a good job of hardening their systems, but not a perfect job. The main problem lies with zero-day attacks. Zero-day attacks take advantage of either new or very recently discovered vulnerabilities in applications, which means that the network and systems probably haven't been hardened against them yet. The unfortunate reality is that attacks keep changing and security experts must be willing to adapt in order to keep pace. The best defense against application attacks begins with the application's developer. Most attacks against applications involve exploiting outside input to the application. By using proper data validation techniques, application developers can stop most application attacks from succeeding. All data validation techniques should be thoroughly tested by the developer to ensure that they are effective. It is even advisable to have an unaffiliated person or organization attempt to bypass the validation techniques in order to increase the effectiveness of the testing. And that concludes this session on types of application attacks, Part 1. We began with application attacks defined, and then we concluded with a discussion on some common application attacks.